Okay, I can explain how it works and where I learned how it works, and I even have a handy sort of visual explanation. Can we all see that? So yeah, I'm going to be explaining warp drive, highly advanced Star Trek technology, and drinking from a very appropriate mug. There's kind of three basic ways that sci-fi shows do faster than light. You've got your wormholes, which the rebooted Battlestar Galactica did. You've got hyperspace, which is what Babylon 5 did, and then you've got warp drive, which is what Star Trek does. And of the three of them, warp drive is the one that might theoretically actually kind of work. So what I've got is I've got this handy visual explanation. You've got the Enterprise here, one picture of the Enterprise, and here you've got planet Dargleblarg, and you want to get the Enterprise to planet Dargleblarg, but you can't because it's 5,000 light years away. And because E equals mc squared, what E equals mc squared means, it means energy, the energy that you need to move something is equal to the mass of that object times the speed of it squared. And because this means that objects get heavier as they get faster, eventually, as you get towards the speed of light, there is not enough energy in the universe to move that object. So if it's, say, my Federation mug, eventually there is not, and that's not very heavy, eventually there is not enough energy in the universe to move that faster than light. And what this means is nothing can travel faster than light. Eventually with physics, it can get so convoluted and so out there that it stops really being physics as we think of it, and it starts being more like philosophy. So what we're going to do is we're going to put a bit of a twist on this, and we're going to change our point of view, and we're going to say nothing can move faster than light, but that means nothing can travel faster than light, okay? And this is the clever bit. Space equals nothing. Space can go as fast as you want it to go, which I'll say again with the visual for that up. Space can go as fast as you want it to go. There is theoretically no limit on how fast you can move space because it isn't anything. So here's another crudely drawn picture of the Enterprise, and this time I've drawn what the warp field.
Okay, that looks like ovaries. You haven't drawn the Enterprise, you've drawn a uterus.
So here we have a crudely drawn picture of the Enterprise being mistaken for the female reproductive system. And what's going on at the front of the ship here? Maybe purple wasn't the best colour, but I tried doing it in black and it didn't stand out. Purple at the front of the ship here. This is the space in front of the ship and it's being squashed. And then at the back of the ship here, it's being stretched back out again. And the Enterprise isn't actually moving. It's taking the space in front of it and squashing it. And then it's stretching it back out again at the back. So it looks like it's moving very, very fast, even if it isn't actually moving. So if we go back to the first visual, we're not going to move the Enterprise. We'll move the space around it. And we're going to move that as fast as we want because space isn't anything, so we can move it as fast as we want. And so by doing that, we bring the Enterprise to the planet.
So what you're saying is I should move the coffee maker into the bedroom
Wait,
so that I don't have to do the traveling to the kitchen in the first place.
Exactly.
wait, Phil.
Actually, it's very clever.
Yeah. So that is how warp drive works. It doesn't.
Wait, I have a real question. Is it like a treadmill where you put a stationary object on the treadmill and space is like the treadmill, sort of?
Kind of, yeah. So like the Enterprise itself sort of isn't moving, but to us it would look like it was.
But there are objects in space, right? Those have mass. Those are things. Those aren't nothing.
Yeah, so you always have to stop warping when you get to them because you can't move those. That's why you can't just warp straight through a planet.
So how are they moving space?
Well, this is when I said it's theoretically possible. That's a good question. How do you move space? We don't actually know how to do that.
The warp core is involved somehow.
Yeah, that's
So
where
that generates a lot of energy for them to move the space.
Yeah, so moving space probably takes a lot of energy, but it probably takes a lot less energy than moving the Enterprise itself would. So you're not moving the ship, you're moving the space around it. You're thinking of the space as the thing that's moving.
But I guess if like what I was trying to ask when I said there are things in space.
Right.
If they're trying to get to a planet faster, wouldn't the space just be moving around the planet too? Not moving
like
the planet itself?
pulling like a tablecloth with like all the stuff on top of it. You know what I mean?
Yeah.
The stuff is still going to be where you left it.
Or is it like when you pull the tablecloth so fast that everything stays?
I think because you're only moving the space in a sort of very small area around the ship. So you're moving a small amount of space really quickly. When you get to where the planet is, when you get to where you're going to start affecting the space around the planet, that's where you come out of warp.
So we're probably not understanding how incredibly vast space is, and that's why, right? Because because most of space is just empty space, right? So
my apartment metaphor definitely falls apart here.
You got stuff everywhere.
Oh yeah, that's a real problem.
Yeah, so I mean, it's not like you're flying past all these planets and stuff. When they do warp, and it seems like they're going, across. They might still only be going, had never encountered any other matter the whole time.
Yeah.
Right. So it's like they're bunching up space just in that one little area, and then the ends of the space are whatever.
Yeah.
Scientific as I can get.
If you want to think about like how vast space is, I learned this the other day. The closest planet to most planets in the solar system is always Mercury, because of the way, and because Mercury is to the sun. Mercury is almost the closest planet to Neptune, for instance.
Right.
Because Jupiter can be all the way over on the other side of the sun.
Right.
That's how big space is. So you're warping in the gap between all those planets. You're not sort of flying. You're not kind of doing like, I suppose in America you call them the Blue Angels, I think. You're not doing Blue Angel, I'm thinking of the Red Arrows in Britain. You're not doing close formation flying.
Yeah, that makes sense. Yeah, the vast majority of space is
Empty.
Nothing.
Yeah.
But I think I got it, kind of. I understand it much better than I did at the beginning, which is really all we could hope for. Nicole still looks a little lost, but...
Truly, you need to know that I took 2 astronomy classes in university to get my science credit for my humanities degree, and this is 100% the face I made through the whole thing. And I think that the only reason the professor passed me is so I would stop calling him Mr. Christie instead of Professor Christie. So this is on brand for me, for sure.